the fluid mech homework. We're given this scenario where we have this object rotating against a stationary surface, and there's an oil gap between the two objects. So h represents this gap, 2 theta is the angle of this object, and this is the angular velocity. R0 is the total radius of this object. We need to find the torque that needs to be applied to this rotating object to keep it at the same angular velocity that it's currently at. To do this, I use Newton's law of viscosity and solve for du dy. Du dy represents the gradient of viscosity change between the two objects. And to solve this, I made the assumption that this was a linear gradient. And so with that assumption, you can find an equation for the velocity at any point of the rotating surface, which is the angular velocity times the radius. And then this stationary surface is obviously going to have a velocity of 0. So du equals angular velocity times radius. Dy is simply h because that's the gap right there. So plug that all in, you get an equation for shear stress. Shear stress is force over area, which is also equal to a differentially small force over a differentially small area. This will come to play in a second. So torque can be written as force times radius. And a differentially small torque is the radius times the differentially small force. And we can combine these equations to find a combined equation for a differentially small section of torque in terms of radius, shear stress, and dA. We can plug in for shear stress, and we get this equation. So now we need to write dA in terms of something that we can integrate over, which is r. And so this is the conical section that dA represents. And if you go through all of the equations right here, dA comes out to be equal to this. And this is in terms of dr and some constants. And so if we plug this in to our equation right here, we can pull out all the constants, which are these, and it's given r to the cubes dr times all the constants equals a differentially small torque. And if we integrate from 0 to r0, which is the total radius of this object, we can get an equation for torque in terms of all of these constants. I hope that I explained everything clearly, and thank you for listening.